Okay, so far in this course or topic we have looked at where there are a single x and we've had to move everything away from that x in the reverse order that things were done to x. We've also looked at when there are more than one x in an equation, say x on both sides or possibly x on both sides of the equal sign. And in that case we would try and collect those x's together and then shift everything away from x. It's just an extra step when dealing with fractions. What we're going to do is multiply by the denominator of each fraction to get rid of the fraction. But the same rules apply. What you do to one side, you must do to the other. So keep the seesaw or the set of scales in balance. To this equation, I'm going to multiply every single term by 2. Okay, that's going to be my operation. So if I do that to both sides of the equation, things should stay in balance and I'll still have an equal equation. So if I just put it in the equal sign, I'll put it right in the middle. And I multiply everything on the left by 2. Now, when I multiply x over 2 by 2, hopefully you can see that it cancels out that 2, and hence the reason I did it. And then minus, and you can see I'm going to multiply that fraction by 2 by just writing it like that. 2x over 5. Just over to the side. I could have also written it like this. Those two things, well, these two things are the same thing. Okay? You could prove it to yourself if you wanted to by putting numbers in for x, like 2 times 3 is 6 divided by 5, 6 over 5, or you could, it's still 6 over 5, it doesn't matter where you write the 2. 2 can go in front or it can go on the top of the fraction. And don't forget, you better multiply this 3 by 2 so that everything in the equation has been multiplied by 2. Totally legit. The equation still is in balance. Basically, in that new equation, this one, I've still got a fraction. I don't like fractions, they're hard to work with, so I'm going to get rid of that fraction in the middle. Get rid of that. To get rid of a fraction, you multiply by what? The denominator. Okay, so I'm going to multiply everything in the fraction by 5. Both sides. Multiply both sides by 5. If I do the same thing to both sides, everyone's happy. The x has to be multiplied by 5, this term has to be multiplied by 5, and 6 has to be multiplied by 5. Okay, let's do it. 5 times x. 5 times minus 2x over 5. 5 times minus 2x over 5. Answer? Yes, minus 10x over 5. But if I simplify it, it comes to minus 2x. The 5's cancel each other out, and hence is why I multiplied everything by 5. 6 times 5? 30. Okay, so in effect, all I did was I multiplied by 2 to get rid of the first fraction, and then 5 to get rid of the second fraction. And now I'm going to collect together the x's. 5 of them minus 2 of them is 5 minus 2? Must equal 30. to get rid of the 3. Divide both sides by 3. Answer x equals 10. Check your answer. Alright, both x's are 10. 10 over 2, 5. And then 10 over 5 is 2. 5 minus 2 is 3. So it works. X is 10. You can see some concerned faces out there. Let's look at another one. We'll take letter B. Okay, 1b. N over 3. I'm going to get someone to help me out with this one. N over 4 equals 2. Hamish, at a guess, what would you do first?
Probably times
Everything by
2.
why 2?
Oh, no. I
Have-
would have said 4, but
Correct. 4. Jono, why would you times everything by 4? Not sure?
The denominator of the things being made.
Yep, yeah. The reason you're multiplying by 4 is because you want to get rid of this fraction. The next step is going to be multiply by 3 to get rid of this fraction. If you multiply a fraction by its denominator, the fraction disappears. It's like saying 3 times 4 divided by 4. Or 5 times 6 divided by 5. It goes back to 6. So they cancel each other out. Okay, answer is 5. The 6's cancel. Anyway, multiplying everything by 4. First term by 4. Second term by 4. Oh, mistake. 2 times 4 is... That's better. Everything needs to be multiplied by 4. Regan, what we do next? That's right, multiply everything by 3 because we want to cancel out this 3. When you multiply that fraction by 3, you get 4n minus 3n. 8 times 3. Right, everything got multiplied by 3. Legitimate working because all the terms, everything was multiplied by the same number, so it's still got a balanced equation. Can anyone see what the answer is? Molly?
is n equals 24.
Correct.
It's like
1n equals 24. So we can check our answer. (24) divided by 3? 8. And 24 divided by 4?
6.
8 minus 6?
2.
Works same. 24 is the answer. I'll just do one from question 2 and then I'll let you have a go. Let's look at... Let's look at 2c. I need everyone to watch this. Well, those that are with me, watch this closely. 2c looks like this. N plus 3 over 4 n minus 1 over 2. Dylan, first step. Say that again.
Divided by 2.
Not divided,
Okay.
times, thanks. So both sides need to get times by 2, and the reason you'll do that, Dylan?
Get rid of the fraction.
Exactly right. To get rid of a fraction, you multiply it by its denominator. So left hand side by 2 looks like this. Now, the reason I asked you to look is that you need to remember the brackets. You need to remember to put the n plus 3 in brackets. If you're going to multiply that term by 3, I suppose another way to write it might be like this. Same thing. Okay, so same as what I showed you on the previous slide. And then on the left hand side, of course, I got rid of the fraction. You're on a roll, Dylan. What would we do next?
Times by 4.
Brilliant. To get rid of the fraction, both sides. Left hand side just gets rid of the 4. What do I have to be careful about on the right hand side? If I'm multiplying that right hand side by 4, yep,
So you have to multiply everything, so like the n and the 1.
n and the 1. So you either write it like this, n minus 1, or you write it as, which is the same thing. Yeah, every term needs to be multiplied by 4. Okay. Now I've got some brackets. I'm just going to cross this bracket out for a moment so that it sort of flows. I've got a set of brackets over here. Recall back to last week when we got a set of brackets. How do we undo or get rid of brackets? Yeah. Again, there's actually 2 options with this, but expand always works. 2 times 3 must equal 4n minus 4. Next step. Next step.
Take away plus. Take away 6.
That would work. As long as you do the same thing to both sides, you could take away 6. I was more thinking along the lines of collecting the n's together. But it's not wrong to take away 6. You'd still get up to the right answer. But I'm going to collect the n's together. There are more n's on the right than the left. So, again, there's a few different ways of doing this, but I'm going to collect them on the right. There's more of them. Watching. Take away 2 from that side. I better take away 2 from the left. From the right. Those ones are gone because I took them away. I've got 6 on the left. 4 minus 2. 2. Okay, so I've collected the n's together. Now I'm going to go and put the everything else on the other side of the equation. To do that, I'm going to add 4. Watching this, Hamish? I'm going to add 4 to both sides. It's the operation. And I get 10 equals 2n. N therefore must equal 5. Watching. 5 plus 3 divided by 4. 2, right? That comes to 2. 5 minus 1. 4 divided by 2. That side comes to 2. So 5 works. Done.